Assalamualaikum and good day. So I'm going to present on my mini project for EEE 219 Python programming for the automated calibration report for transmitters. My name is Muhammad SUNIZAM bin Shu, a student ID 082200058, class code PYT 11-3C. My tutor is Muhammad Yusuf bin Omar, and the course coordinator is Dr. Muhammad Hazvi bin Mazaki. The reason I choose automated calibration report for transmitters for my mini project is, as I usually do manual record for my calibration works for transmitters at my workplace. So it is sometime we lost the record, and in the long run, it will lose the historian for the calibration work done for the transmitters. So by doing the automated calibration report, so I am utilizing the Python programming knowledge that I have, so that we can improve the process and procedure for the calibration works that going to be done at my workplace in the future. So the contents of my presentation will start with an introduction and following with material and methods, and then with results and discussion before we come to the conclusion and the acknowledgement. So introduction. So in many industries, the calibration of transmitters is still recorded manually by technicians using paper-based logbook or spreadsheets. This method has several drawbacks. Number one is risk of data loss. Physical logbook can be misplaced, damaged, or destroyed, leading to missing calibration records. Number two is human error. Manual data entry increases the chances of incorrect values, leading to inaccurate calibration results. Number three is inefficiency. Searching and retrieving past calibration records from paper-based system take time and effort. And the last one is compliance issues. Many industries require structured calibration records for audits and regulatory compliance, which manual logging does not always meet. So by automating the calibration recording process, this issue can be minimized, ensuring accurate, efficient, and well-organized calibration documentation. This project aims to develop an automated calibration report using Python to simplify the process. The system will log calibration data, analyze accuracy deviation, and generate calibration report in Excel format. By automating this process, the system improves efficiency, reduce errors, and enhance reliability in calibration documentation. So material and methods. So hardware that we are going for this project is the install industrial transmitter, for example, pressure, temperature, and flow. And then the calibration device, such as the palm and the decad box. Number three is the computers for running the Python script. So for the software, we are using Python 3.13.2, and external modules that we are going for this project is Pandas for data processing. And the reason we use Pandas is it is for handling and processing calibration data in a structured format, and is enable easy data manipulation, filtering, and error analysis. It also allows efficient data storage using data frames for processing large sets of calibration records. And we are going to use OpenPixel for exporting the process calibration data into an Excel files. So OpenPixel support reading, writing, and modifying Excel files dynamically, and allow creation of formatted report for better readability and compliance. And of course, we are going to use Python idle as the development environment. So methodology, step-by-step process. So I am using existing data that I get from my colleagues from offshore. So the user input calibration data, such as transmitter ID, measured and standard values, system processes and validated data. Number 3, calculate error using the formula error measured value minus standard value, divide by standard value times 100 so that we can get the percentage of error. And check the pass and fail criteria. For this project, I will use plus minus 5% tolerance limit. And last one is to generate and save report in Excel format. So I may follow chart for automated calibration report for transmitter. So I will compare it side by side with the code that we already produced. So input that user input calibration data. So this is the how many numbers of transmitter that we are going to input for this trial, for this calibration data report. So in the maintenance plan, usually we have around 4 or 5 transmitter to be done at the same time. So for this example, I will use 4 transmitters and process and validate data. So during this process and validate data, we will enter the transmitter ID, that is the tag number, enter the measured value, one that we manipulate on site using palms to get the pressure that we want, and then we enter the standard value. So and standard value meaning this what the transmitter should display if we already enter the measured value. So we are going to get the error of measured value and standard value. So the next step is calculate error deviation. So calculate error deviation, as I told before, the formula to be used is measured value minus the standard values, then divide by standard values times 100%, times 100, so we get the percentage of the tolerance limit. Then after we have the percentage of tolerance limit, the next step will be check pass or fail criteria. So if it's within 5 plus minus 5% tolerance limit, it is considered pass. Else, it is fail and required for calibration. So after we get all the pass and fail, and we have done for all the numbers of transmitter, so we are using the OpenPixel to generate Excel report and save to Excel file, and then export to export and store the data using OpenPixel. So now I'm going to demonstrate on the code that we already have here. So I will run the modules. So enter number of transmitter. So we will enter 4 transmitter. So for the first one, I will use tag number transmitter 001. So for example, I get 45 bars, and the standard value is 50. So the next one is transmitter 002. And for this one, I will assume that all the reading is 50 compared to the standard value of 50 also. And for transmitter number 3, PX003, I will use as 60 as our measured value, and the measured value is 50. And the last transmitter is TX004. And for this one, I will also put as 50 and the standard value of 50. So from what we have entered, the report generated has been report already generated. So now I am going to the file, the Excel file where the report already generated to see what we have. Okay. I'm opening the Excel file now. Okay, so this is what we have entered before. So from here, for transmitter 001, that we enter measure value of 45 and the standard value as 50, we have around negative 10 percentage of error. So as our pass and fail is determined by plus and minus 5%. So the status here indicate as fail. So for transmitter 2, as the measured value and standard value is the same, the error is 0, so it is status pass. Transmitter 003, we simulate it to have a reading of 60 and for the measured value and standard value as 50. So we have around plus 20% error. So it is indicate as fail. And transmitter number 4, the measured value and the standard value is the same, which is at 50, and the error value is 0, which is a pass. So this is our generated report using OpenPixel. So we will save this and use this as the calibration report and attach it in our maintenance report. So back to our presentation. So to validate the system, sample calibration data was used. So this is the earlier sample that I used before with the error percentage of 2 plus minus 2%, but I already adjusted it to 5% in our simulation previously. So it is evident that the system correctly identified calibration pass and fail status based on predefined tolerance limit, which is for my example is plus minus 5%. Advantage of automation over manual reporting is faster processing of large calibration dataset. And it reduced the human error in calculations, standardize the report formatting for compliance documentation, and easy integration with industry system for seamless data management. Discussion and benefit for the automated calibration report is number 1 is faster and more reliable calibration report generation. Number 2, reduce the human error in data entry. Number 3, structured report format for compliance and scalable to multiple transmitters. So regardless of numbers of transmitter that we have in our maintenance plans, regardless of 5 or 4 or 10, we can use the same report to record the the finding that we have. The limitation and for future improvement, currently it is support only on Excel report. So future update, we might want to consider PDF generation. Number 2 is no real-time sensor integration, meaning that we have to record it manually. Still, we record it manually, but we record it in Python environment. So this is another potential upgrade that we might have in the future. So for conclusion, the summary of project contribution: automated calibration logging process, accurate and efficient reporting system, and reduce workload for engineers and technicians. So future development, we might include the cloud storage for remote access and integration with Internet of Things, IoT for real-time calibration tracking. Lastly, I would like to acknowledge my tutor, Muhammad Yusuf bin Omar, and the course coordinator, Dr. Muhammad Hazri bin Mazaki, for guidance and support throughout the completion of this mini project. I also would like to thank my Malikai operation technician colleagues for providing me the data for the simulation and implementation of the automated calibration report on the site. Final word from me is automation in calibration reporting, improve accuracy and efficiency. So let's embrace technology for better industrial practices. So that's all from me. Thank you. Have a nice day.